So last week we started with limits from a graph. So you just had a picture, look at the picture, think about what's happening from the left versus what's happening from the right, and if they match, then whatever number they're headed toward is the answer. What's the answer if they don't match? Like if the limits are going different places? Doesn't exist. Okay, so that idea we got to carry through to today, where we're going to look at limits given a table. So Monday was from a graph. Today is from a table. And just a little heads up, notes 3 will be limits from an equation. So we're sort of gradually stepping up in difficulty. Thursday was, hey, here's just a picture. Look at the picture. Today is, here's a table. So you got to think a little bit more. And then tomorrow we got to think a lot more when we have an equation.
For the quiz, like on Wednesday, is there going to be stuff that we learn on, like the quiz, like that we learn on Wednesday on the quiz?
No, because we do have a quiz coming up, so may as well address it. We were going to have 2 days on algebraically, so we'll cover everything on Tuesday, and then Wednesday we'll have time to answer a bunch of questions, and then we'll take a quiz over it. So there won't be anything new presented on Wednesday, but it's a lot of stuff on Tuesday. So Tuesday will be a lot of stuff, but we'll have a couple of days to process and think about it. Good question. Okay, so graph, pretty easy. Table, not too bad. Equations, a little trickier, but we're not worried about that yet. Building up to it there. We need to be able to determine limits given a variety of pieces of information. This is what I just said. Graphs, that was Thursday. Equation, that's coming tomorrow. Table, that's today. And sometimes we get crazy and like kind of mix it up and see if we're really paying attention as to what's going on. But today's section is tables. And a calculator would be helpful today. Although if you don't have one, you can just write down the answers and you'll be okay. But it would be good to make sure you know where all the buttons are. Which means, so the question was, will we get a calculator on the test? A lot of times we can avoid giving you a calculator and we just fill in the table for you. So you don't need a calculator. So I don't know, but probably not. We'll probably just, a lot of times in pre-cal and even in calculus, they'll just fill out the table for you because that's the easy part of the question. Okay, consider the function f of x is x plus 5 over x minus 3. From previous knowledge, we know there's a vertical asymptote, right? Because that factor doesn't cancel. So we know at x equals 3 there's a vertical asymptote, but what would this look like in a table? So I think the easiest way to do this, let's go to y equals and put that in. The fraction bar, sometimes it's overused, but sometimes it's helpful. Alpha F1, get you a fraction bar if you like that. It's probably easier than dealing with parentheses. So there's our function. Now I could type in all of those things, but the table would be nice. But go to table set and let's change the independent, right? The x is the independent variable, y is the dependent variable. Let's ask for the independent variable. That way I can type in all the things I want. So it won't give me this pre-made table, but I don't really want a pre-made table. I want a specific table for me. So second table set, ask for independent, and then when you go to the table, it's blank. Like, well, that's not helpful. But now you get to type in what you want. So if x equals 2, y is negative 7. So we're building our table here. X equals 2.9, negative 79. 2.99, negative 799. I bet I could guess what the next one is without typing it in. Sure enough, negative 7,999. Okay, so before we even jump to the other side here, our x values on this side are approaching, what are we approaching? 3, and 3 from which side? The negative side is, we're a little less than 3, so the negative side, the left side. So as x approaches 3 from the left, my y values, in fact, this is the first question here, the limit as x approaches 3 from the left. In fact, let's stop there. I don't need what's going on the right-hand side. That's over here. X approaches 3 from the right. But I don't need that yet to answer this first question. What's the limit as x approaches 3 from the left? What are those points doing? Negative infinity. They're getting bigger and bigger in the negative direction. Their magnitude's getting bigger, I should say. So that's running off to negative infinity. If we did a graph, that would look like that. All right, let's try the other side. And I'm going to start at 4. Maybe that feels out of order, but I'm going to approach 3 from the right. So if I plug in 4, I'm at 9. Plug in 3.1. I'm at 81. 3.01. 801. I think I know what the next one is. Make sure. Yep, 8001. So as we approach 3, this feels backwards maybe because we're approaching it from this way. As we approach 3 on the right-hand side, we're a little more than 3. My values are going up, 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 up. They're headed toward positive infinity. So what would you say the limit is as x approaches 3? Definitely does not exist. Sort of like double does not exist. Even if they were both going to infinity, we could say that doesn't exist. But certainly if they're going to different infinities, it doesn't exist. If even one of the one-sided limits is infinity or negative infinity, the limit does not exist. Think about what that would look like. So like if it was an asymptote on one side and maybe something more normal on the other side, that limit doesn't exist. The limit from the right exists, but the overall limit would not exist. All right, consider this function. We know there's a vertical asymptote at -2, right, because it didn't cancel. What would that look like? Well, let's go find out with a table. X minus 4, x plus 2 squared, and table. I don't really want any of those. Delete. I can delete all of those. So I'm approaching -2 from the left on this one. So -2.1. I'm up at 190. -2.01. This thing's blowing up in a hurry here. 19,900. 2e6. Put this in right? Oh, I'm not right. I'm wrong. Because I typed in the formula wrong. Should be x minus 4. Oops, I don't even want the graph. Although that gives me the answer. Table.
Wait, will we use calculators?
So I can avoid giving you a calculator by filling in the table for you.
But is that what's gonna happen?
If I want you to use if I give you a blank table, then I'll give you a calculator. 6E6. So that's this is really big. No, that's 6E5. I need another 0 on there. Either way, it's the same result. So on this side, x is approaching 2, negative 2. From the left or right? From the left, because we're a little less than negative 2. In fact, again, let's pause there and answer the first question. So as x approaches negative 2 from the left, what are we headed toward? Negative infinity. We're going way down, way fast. On the other side, if we're a little more than negative 2, and I'm not going in the order that's on the page because I like going in order of thinking about as x approaches negative 2 from the right. So each time I plug something in, I'm getting closer and closer to negative 2. Oh, another 6E6. That's probably rounded, but I don't. That's fine. It's fine if it's rounded because I get the idea. As we approach negative 2 from the right, we're headed toward. We're also headed toward negative infinity. So, this is a bit of a trick question. The limit as x approaches negative 2 from the left is? Good. It does not exist. You could put negative infinity in parentheses because that's why it does not exist. Maybe that's a better way to say that. So it doesn't exist. The reason it doesn't exist is it's going to negative infinity. So it's kind of a different D&E than the last problem, but it still does not exist. Okay, we're done with the calculator because now we just fill in the table for you here. Number 1, the table gives values of a function at selected values of x. Which of the following conclusions is supported by data in the table? Let's see. As x approaches negative 9, the limit is 6. What do we think about A? We're just going to have to go through these individually here. Maybe we should label some things. So there's kind of the break. So as x approaches negative 9 from the left, what are my y values approaching? All right, let's go one piece at a time here. So on the left-hand side, what do we think we're... Looks like we're approaching 3. On the left-hand side, on the right-hand side of the graph, as x approaches negative 9 from the right, what are my y values approaching? 6. Okay. Maybe we should have done that first. Now we can answer these questions. So question A, limit as x approaches negative 9 is equal to 6. Yes or no? No. Like on one side, yes, but on the other side, no. So A's out. Limit as x approaches negative 9 equals 3. Well, also no for the same reason. Like one side is 3, but the other side is 6. So, okay, here we go. X approaches negative 9 from the left is 6. Negative 9 from the left would be smaller than negative 9. That's supposed to be 3. So the answer is D. So that would be an example of a question where you don't have a calculator, but you don't need it because we filled in the table for you. All right, why don't you try 2, 3, and 4. So you try 2, 3, and 4. I'll hit pause and then we'll compare answers. Limit as x approaches negative 5 for h. So again, make sure you're looking at the right table here. So what are we approaching as x approaches negative 5? A. Well, I'd say A from the left, but from the right, 4. So if it approaches 3 from one side and 4 from the other side, what's that mean? It means it doesn't exist. We're headed toward 3 from one side and 4 from the other side. That there's something weird going on. That does not exist. Evan, were you able to figure out number 4? It is A. Very nice. That nested thing, so start in the middle. So limit as x approaches 7. So we kind of want, it's not really g of 7 because we don't have g of 7. But as we approach 7, the y value is approaching negative 5. And so then we want the limit as x approaches negative 5 for f of x. So we switch over to our f function, and we're approaching 6. And this is one that could have been one of those weird ones about, well, it's always below or above and which side, but it didn't matter because it would approach 6 either way. So that was a straightforward one. I suspect 5 might be a weird one. Let's see. H of g of x, and as x approaches 7. So let's start on the middle, or start on the inside. Limit as x approaches 7 of g of x. They're both headed toward negative 5, like both sides. So that limit is negative 5. So then we'll take the next step out. Limit as x approaches negative 5 of h of x. And that's, okay, that would be d and e because they're different. But if we back up to as x approaches 7 on g of x, they're both a little less than 5. So we're always a little less than 5, which means we're approaching 3. That is kind of a tricky one. We had to think about always a little less than 5. We had to word these carefully because we don't know exactly what's happening at each of those places. And so we word them like, which of the following conclusions is supported by? We don't know that those are absolutely true. Because maybe as we zoomed in, like maybe it's headed toward 4, but if we zoomed in really close, it was actually headed toward 10. Like if our x values were like 4.999 and this is x value of 5, so like, does that make sense? Like our table doesn't guarantee that that's our answer because our table doesn't see what's happening past 4.999. So while it looks like the answer is headed toward 4, we don't really know that unless we had a graph or more table. But even then, you could always say, well, at 4.9999999. So that just explains sort of the weird wording that we picked. Conclusion is supported by. Because you can't say for sure what the limit is based on a table. Because you don't know. All right, you can get started on worksheet 2, and I will pass back your tests.